perpetual motion device. And the physical cause for this appalling behavior will be traced back to quantum coherence in the presence of a near equilibrium bath. And it's emphasized that quantum coherence is reflected in the quantum noise correlation and so forth, more technical details. But the most important part is that we're literally describing something that's very similar to a micro laser cavity. That's literally what we're looking at here, is a micro laser cavity. And all we're proposing is this unusual phrase called quantum coherence. Well, that simply is a phase difference. And if you allow for a phase difference, you can then have a temperature difference internally that basically rotates or circulates radiation. And so radiation essentially is the medium to drive the piston. Radiation pressure is what drives this piston. So once again, this is a theoretical model. However, it is so provocative that it's also provoking other experiments. And as we look at the micro laser, here's an artist rendition of what a micro laser would look like. 2/millionths of a meter across and about 100 nanometers thick. And these micro lasers basically achieve the lasing without inversion. And this is a major breakthrough because quantum mechanics is being applied here in a new application that essentially doesn't seem to make sense in terms of people who are used to the old style of lasers that required inversion. Now here's another one that uses a micro laser, and once again, this particular article, which was in Physical Review B, 1999, it's Dr. Pinto's article, mentions free energy in the abstract. He says if this thing works, it'll basically provide unbounded free energy. And I was very pleased to see his courage at getting Physical Review even to include that and not edit it out. Now this cavity tends to be a little bit complicated. I would criticize Pinto because of the complex nature of this cavity. We're seeing something very similar to forward, where you have a membrane or a plate that's being moved by charge and the Casimir force. In other words, there's a movable plate, Casimir force here, charge upwards, and we're applying a little bit of voltage as well. Now the trick here is, and this is a zero-point energy trick, you discover these in the literature, and of course Pinto is now using one of them. The trick is that as you turn on your micro laser, you change the dielectric properties of the surface and instantly increase the Casimir force. Just turn a light on and you get a bigger force. Hello, free energy? Pinto probably couldn't sleep for a few days after he discovered that. And just changing the dielectric properties, all of a sudden the Casimir force gets bigger and pushes this thing upwards just because this little light went on. So this is literally the entire secret to his whole, I think it's a 15-page article, is that altering the physical parameters therefore changes the total work done, and it's unique to the quantum world. You can't do this in the macroscopic world. You have to do it on the microscopic, nano size invention. And of course, this also involves the radiation of virtual particles. And of course, even as you do the thermodynamic closed paths, the total force does not vanish. So you are getting energy out. Now, how much energy out? Right now, he's estimating 1/2 nanowatt, 10 microjoules per centimeter squared. If you look at the surface area here, this is 50 to 100 microns. And so it's still on a microscopic scale. This is not a nanotechnology device. This is really a micro technology device. And the application, perhaps most important, is not only the frequency of kilohertz, but also the hope that you can multiply these to have them all working significantly in series or in parallel. And so Pinto literally today is building these and hoping to see a breakthrough. Now, along the same lines of moving something, the very fascinating, I would say, family of technologies that's also available today is the fluctuation-driven electricity. And as we look at the reasons for it, there's, first of all, the fluctuation theorem that has basically described experimental proof that as you perform experiments on something where you deliver heat to a system, half the time heat is also delivered back to the source. It's a probabilistic type of system. And this was in Physics Today, actually, the article describing the fluctuation theorem. And so I found this very fascinating. In fact, here's the article, Crookes Physical Review E, 1999. So the negative work concept is free energy. When you're not working, you're basically relaxing, and somebody else is giving you the work. And this is essentially what they're describing here. So there's a number of examples. This is one system which Linke in Science in '99 has proposed, that if you design a ratcheting system, which they experimentally did, this is a ratcheted semiconductor layer of pockets to allow for a particle to keep moving along the road if you apply a fluctuating potential. And once again, you see this up here as well. As you apply a fluctuating potential, you get a net current. So overall, the input force can be zero, but you also do get motion. And so on the nanotechnology arena, we're seeing the quantum ratchets being a buzzword. That you can also now prove that thermal noise can be rectified. And to me, this is the most exciting, simple, clear-cut direction that all zero-point energy nanotechnology research should actually pursue. And associated with this in Linke is also the fact that as we look at the type of devices he's working with, there's about 0.2 nanoamps or a picowatt that he also develops. And I promised I would review basically the perpetual motion concepts. It obviously exists in electron motion consistently. In fact, there's now research that Puthoff has published showing that every single electron level is being bolstered by the zero-point field. And right now, we basically already have perpetual motion devices of the second kind, where, for example, in laboratories for over 10 years, a superconducting current has circulated with no need to add extra energy. And this has also baffled the industry because they always thought they'd have to get rechargers for the NMR units, the MRI, it's now called, for units. So this is completely converting energy from one source to another, and we're thinking that that would be the violation. Actually, this is the third kind, I'm sorry, where it continually moves forward in one direction. And what we're finding is the second law is now being eroded by a couple of the inventions I showed you, especially when you're dealing with the steam temperature. And the conservation of energy, which basically is the perpetual motion law of the first kind, is being violated, but you have to account for the zero-point field as a source of energy. And so in 1998, the big buzzword was the universe is accelerating, and Einstein was right. The cosmological constant should have been included in the general relativity equations. And yet he took it out. So originally in this article, they actually talked about zero-point energy being the source of the problem, why the galaxies were expanding. However, as time went by, the astronomers decided to change their language and call it dark energy. And I've been at more than one conference where I keep asking them, why are you calling it dark energy? There's no such thing. You know, it's zero-point energy. And they said, well, we wanted to keep it vague. You know. Let's confuse the issue. That's scientific method, all right?